Hello, everyone. Thanks for tuning into our talk. In this presentation, I, Almaz Mesghina, and my collaborator, Dr. Emily Lyons, will be presenting findings from a series of studies that examine factors contributing to the emergence of gender differences during children's learning from one conceptual mathematics lesson. So we know that math trajectories are patterned by gender in complex and sometimes even paradoxical ways. So math-intensive fields remain heavily male-dominated. And as the graph shows, this is a pattern that has persisted over time. Yet research shows no meaningful differences between genders in their math aptitude, but instead indicates that mathematical reasoning develops from a set of biologically based cognitive capacities that males and females share. Moreover, despite continued underrepresentation in math fields, in many cases, females actually show higher math learning and achievement. Indeed, measures of mathematics achievement requiring sustained effort in low-stakes settings often favor girls. These include things like grades, time spent on homework, and high school and college completion. But the gender gap often reverses on high-stakes measures of mathematics achievement, such as standardized test performance and math competitions, where we find that boys actually outperform girls. So this reversal of the gender gap across high and low-stakes settings highlights the importance of considering the role of student attitudes and contextual factors to understanding math learning and performance. In our lab, we are very interested in understanding how to best support students' math learning and achievement. We examine children's learning from a conceptual math video lesson, as you can see here. Across many studies we completed in the past several years, something unexpected kept jumping out at us, which is that on all assessments of learning following this video lesson that we give students, we always find that the girls outperform the boys. Now, these studies weren't originally designed to explore gender differences in math learning, but here we decided to pool all the data together to better understand what might explain these very consistent gender differences we find. So all these studies kind of followed a similar protocol that I'll describe here. So students first take a pretest, and then a few days later, they have a math lesson and complete an immediate post-test. And then a week later, they complete a delayed post-test. And spoiler alert here, we notice that they do similarly on the pretest, but that girls outperform boys in the immediate post-test and the delayed post-test. So the video lesson covers ratio and was designed to promote enduring conceptual understandings through incorporation of desired difficulties, such as comparing and drawing connections across multiple solution strategies. The lesson was originally recorded with a middle school math teacher and a group of students recruited for the purpose of the video. So students who participated in our studies watched the lesson alongside their classmates on computers in their everyday math classrooms, which allowed for a lot of ecological validity with our studies. So the series of studies we will be presenting on today explore what might be shaping these gendered patterns of math learning. So in study 1, we zoom in on the role of individual differences, considering student attitudes, executive functions, and engagement. To do this, we analyze data of the non-experimental conditions from the 7 studies that use this video lesson. In study 2, we consider the role of context, specifically the extent to which learning is high stakes or pressured. And Emily will present on our findings from study 2. So again, study 1 is sort of an exploratory attempt to see if any individual differences measures we've collected from students could help explain these recurring gender differences we're seeing favoring girls. So we collected a wide range of both cognitive and non-cognitive measures from 447 5th and 6th grade students in our last 7 studies that we've conducted in the lab to narrow in on what student characteristics could possibly be driving these differences in learning. We consider study 1 to be relatively low stakes. So these students were provided no pressure to perform, and they were told that their performance would not be reported to anyone. They were simply just asked to try their best on the lesson and test. On session 1, before the pretest, we collected measures on students' learning attitudes and approaches, including their learning orientations, their academic efficacy, their novelty avoidance, and their math anxiety before they took the pretest. On session 2, which was immediately after the post-test, we narrowed in on possible differences across students in their interest, in their engagement, and in their confidence in their performance. And during the last session, we explored whether students may differ cognitively, So before taking the final post-test, students completed baseline measures of their attention and inhibitory control and their working memory capacity. So just to take a moment here and remind you guys, this data is obtained from 7 different studies. So I'll note here that not every single study used all of these measures. So in subsequent slides, we'll include sample sizes so that you may account for differences in what measures were used when. Okay, so before I talk about those new measures, I want to show students overall learning from the math lesson. So in all subsequent slides, you're going to see that girls are going to be represented in the red and boys are going to be represented in the blue. So across all students, we again see girls learning and retaining more during the lesson, as evidenced by significant differences in their test performance at immediate post-test and delayed post-test. Importantly, these differences in learning can't be explained by prior knowledge, as we see that boys and girls had similar pre-test performance. Rather, the gap seems to be emerging during a single lesson. So what could be explaining this gap? We looked at the role of learning orientations, including students' mastery, performance approach, and performance avoid orientations. Also their academic efficacy and their novelty avoidance. And we also examined students' math anxiety, as prior work has shown that girls tend to be more math anxious than boys. But in our sample, we did not find any gender differences on any of the learning attitudes or approaches measures. So what we're finding here, at least, is that how one approaches the learning context and one's attitudes towards math don't seem to be explaining these observed gender differences in learning. So next, we explore whether individual differences in students' baseline cognitive abilities might predict gender differences in their learning. So we explore differences in students' attention and inhibitory control and their working memory capacity. And I just want to note here that only one study had looked at the working memory capacity. But in either case, we see no gender differences in either of the executive function measures, suggesting here that individual cognitive resources likely do not contribute to gender differences in learning. So finally, we explore more motivational elements, examining whether students' interest and engagement relates to the gender differences we see in their learning. We examined 3 outcomes: students' self-reported levels of enjoyment after the lesson, students' intention to explore related math content after the lesson, and students' confidence in their performance. So here we see that boys and girls reported enjoying the lesson equally and were equal in their desire to pursue similar topics later. However, we do find a gender gap in students' confidence, with boys rating their performance higher than girls. As a reminder, we assessed their confidence right after they completed the immediate post-test. So students used this Likert scale to report the extent to which they thought that they did well on the test. Again, boys did feel significantly more confident than girls, even though boys overall, and in this sample specifically, performed worse than girls. And indeed, we do find that boys aren't very accurate in their judgments of their ability. For boys, there is no correlation between their confidence in their performance and their actual performance. But for girls, there is a positive relationship between confidence and actual performance. So indicating that girls seem to have a better grasp of what's going on in the learning context than boys. So to conclude from study 1, we find a gender gap in math learning favoring girls. So across all students assigned to non-experimental conditions in the last 7 studies that we've conducted in our lab, we're finding that compared to boys, girls are learning and retaining more from the brief but conceptually rich mathematics lesson. We also find no gender differences in prior knowledge, executive functions, learning orientations or attitudes, or reported interest in the lesson, suggesting that none of these sort of intuitive motivational or engagement factors explain why girls are outperforming boys. The only individual difference we are finding is that boys report being more confident in their performance than girls, despite being lower performing. But we only found this in one subset of the population, so we take this with a grain of salt. But as a reminder, these patterns we observed here in study 1 were observed in a relatively low stakes context. So now I'll turn it over to Emily, who will see how pressure in the learning context might change the gendered patterns in math learning that we observe.
So in study 1, as well as the other studies where we informally observed gender differences, learning was very low stakes. Students knew their grades wouldn't be affected, and that neither their teachers or parents would be told about how well or poorly they performed. And we didn't do anything else to heighten pressure. In study 2, however, we experimentally manipulated increased pressure, either before or after the mathematics learning opportunity, to test impacts on the gender gap. We often think of pressure as something bad, something that should be avoided, but pressure really has the potential to either facilitate or interfere with cognition, depending on whether it is experienced as motivating or as threatening. So on the one hand, pressure can indeed act as a threat. This can lead to intrusive thoughts that tax executive functions, cognitive resources needed for attentional control, manipulation of mental representations, and task switching. We would expect this, and it has indeed been shown to, interfere with learning. But on the other hand, pressure can also act as a motivator, leading to increased effort and focus, and this would improve learning. Indeed, prior research has demonstrated both negative and positive impacts of pressure for math achievement. Much of the prior research on pressure and academic achievement has focused on testing situations, and many of these studies indicate that pressure can harm test performance. But on the other hand, several studies show that pressure also has the potential to boost performance. As one example, in a large randomized field experiment, researchers found that raising the stakes of performance by introducing the possibility of earning incentives improved test performance among elementary school students. Much of this work shows a larger performance advantage under pressure among males. This has been hypothesized as possibly stemming from different time sensitivity to rewards, or to males putting forth less effort in low pressure settings. So while the earlier studies that Almaz talked about all took place in low pressure contexts, in study 2, we experimentally manipulated increased pressure to test impacts on the gender gap. Participants here were 178 diverse 5th grade students. Students in this study were randomly assigned to one of 3 learning conditions. So either learning under pressure, the no pressure, similar to previous studies, and testing under pressure. So it's important to note that in each classroom, there were students in all 3 learning conditions. In this study, we increased pressure by telling students either before the lesson in the learning pressure condition, or after the lesson before the immediate post-test in the testing under pressure condition, that their performance would determine whether or not their entire class received a pizza party. So here's the particular prompt students heard to heighten pressure. I'll give you a moment to look it over. And so what we found here, first, I'll talk about findings in the no pressure condition. So this is a learning condition similar to the earlier studies that Almaz spoke about. And as in the previous studies, girls exhibited higher learning gains. They're especially pronounced immediately after the lesson, and we see these same trends at the delayed post-test. In addition to exhibiting higher learning in the no pressure condition, girls also showed higher math engagement, being more likely to choose to engage with optional math puzzles after the lesson, and showed trends towards reporting a greater desire to learn more about the topic. However, when pressure was heightened either before learning or testing, these gender gaps either disappeared or reversed. So among students assigned to the learning pressure condition, so this is when pressure was heightened before the lesson, girls showed trends towards higher immediate gains, and there really weren't any differences overall. Additionally, among students assigned to the learning pressure condition, boys actually exhibited higher motivation to engage in the non-required math activities. So boys were doing more of the puzzles here, which is opposite what we saw in the no pressure condition. For the testing pressure condition, I'll speak about briefly, largely the same as the learning pressure condition. Similarly, boys and girls showed similar gains, so there's no longer that female advantage in terms of learning. And we see trends towards boys reporting higher engagement, specifically enjoying the activity more when pressure was heightened before testing. So now you might be asking whether these different patterns in the low versus high pressure context are due to positive effects of pressure among boys or to harmful effects of pressure among girls. And well, it definitely seems to be a little bit of both. So I'll show these graphs to give you a better idea. So as you can see here, there's some evidence that pressure prior to instruction really did harm learning among girls. So these are significant differences here with the girls exhibiting smaller, immediate, and sustained gains in the learning pressure condition than they did in the testing pressure condition. It's less clear, but the trends are also towards pressure before learning boosting learning among boys, although these differences here are not actually significant. Similarly, when pressure was induced before testing, the trend suggests that pressure may have harmed performance for girls while boosting performance for boys, although it's also important to note here that these gaps are not actually statistically significant. They're just trends. So these findings really highlight that pressure has the potential to have both beneficial and harmful impacts on math achievement. And they suggest the possibility that not feeling pressured enough may contribute to males' relative underachievement on measures of mathematics achievement requiring sustained effort in low-stakes settings, while experiences of too much pressure, possibly intersecting with mathematics stereotypes and gender stereotypes, may contribute to females' relative underachievement in high-stakes mathematics situations, such as an eventual attrition from math-intensive fields. So future research that probes in depth what exactly it was about pressure that interfered with girls' learning and engagement while supporting those of boys could help to identify ways to support mathematics achievement for all students across both high and low stakes situations. And before we end, I'd just like to acknowledge the students, teachers, and schools who participated, as well as Learning Lab research assistants who worked on this project. And finally, if you have any other questions about this study or the work we are doing, we would love to hear from you. Please feel free to send an email to either myself or to Almaz. Thank you.